Hello everyone, in this video we are going to solve an important previous year JEE Mains question based on the binomial theorem. We will carefully understand the concept involved in the problem and learn an easy approach to solve this type of question step by step. This question was asked in January 2026 session, so it is very useful for all the JEE aspirants. This question is not only about the finding the answer, but also about the learning how to think deeply while the solving the binomial problems. Let's get started. Now, let us carefully observe the questions. In question given that CR denoted the coefficient of x power r of this binomial expression 1 plus x power n, and also given that Pn, one expression is involved in CR, then find the value of 1 over p of 2n and summation run for 1 to 25. Now this question is mainly based on this Pn, so we focus only this Pn. So Pn is equal to C0 minus C1 plus 2 square over 3 C2 minus 2q over 4 C3 and so on minus 2 to the power n over n plus 1 Cn. Therefore, we write this expression in summation form. Then summation we vary r is equal to 0 to n minus 2 to the power r over r plus 1 Cr. So if we put n is equal to 0, then this expression is C0. If we put n is equal to 1, then this expression is C0 minus C1. So if we put here r is equal to 0, then this expression is C0. R is equal to 1, this summation gives C0 minus C1. So it is verified that this Pn is right correctly. Now we apply a binomial identity here such that this expression is converted to nice form. Now we write a note. This binomial identity is NCR over r plus 1 is equal to 1 over n plus 1 C r plus 1. So we use here CR is equal to NCR. It is denoted the binomial coefficient of this expression. So this expression means NCR. Therefore, write this summation and use this identity. This summation convert to r is equal to 0 to n minus 2 to the power r 1 over r plus 1 Cr, that means 1 over n plus 1 C r plus 1. Now see carefully, the summation run for r is equal to 0 to n, so this variable is r. So 1 over n plus 1, this term is come outside the summations. Therefore En is equal to 1 over n plus 1 summation run for r is equal to 0 to n minus 2 to the power r n plus 1 C r plus 1. Now we break this summation n plus 1. If we put r is equal to 0, that will be gives 1 n plus 1 C 1. If we put r is equal to 1, that is minus 2 n plus 1 C 2 and so on minus 2 to the power n plus 1 C n plus 1. Therefore write n plus 1. Now we write this expression again in summation form and see the how it is changed. It is run for 1 to n plus 1. So we change the variable r to s. S is 1 to n plus 1 and nth term is always n plus 1. So that is n plus 1 Cs and involved is it is 1 then minus 2 up to minus 2 to the power n. So it is run from s is equal to 1 to n plus 1. So that is minus 2 to the power s minus 1. Therefore, it is 1 over n plus 1 summation run for s is equal to 1 to n plus 1 minus 2 to the power n by minus 2 n plus 1 cs. So Pn is equal to, we get 1 over minus 2 n plus 1 summation run s is equal to 1 to n plus 1 minus 2 to the power n plus 1 cs. It is 2 to the power s. Sorry, 2 to the power s. Now it is numbering is 1. Now see carefully, 1 minus 2 to the power n plus 1. If we break it is binomial expansion, then it is summation s is equal to 0 to n plus 1 minus 2 to the power s n plus 1 cs. If we break it, here suppose we write the general form 1 plus x power n plus 1 and put x is equal to minus 2, then it will gives 1 n c 1, it is n plus 1 c1 x plus n plus 1 c2 x square up to n plus 1 c n plus 1 x to the power n plus 1. Here we put x is equal to minus 2, then it is gives this form. If we write this expression in summation form, then we will get this summation s is equal to 0 to n plus 1 minus 2 to the power s n plus 1 cs. Therefore, that is minus 1 to the power n plus 1 is equal to summation s is equal to 0 to n plus 1 minus 2 to the power s n plus 1 cs. But our Pn is run from s is equal to 1 to n plus 1. Here s is equal to 0 to n plus 1. So we break it, s is equal to 1 to n plus 1. This imply minus 1 to the power n plus 1 is equal to 1 plus. Why 1? Because when you put s is equal to 0 in here, so it is 1, n plus 1 c0, that is 1. So that's why it is 1 and rest of are same. So s run from 1 to n plus 1 minus 2 power s n plus 1 cs. This implies minus 1 to the power n plus 1 minus 1 is equal to summation s is equal to 1 to n plus 1 minus 2 power s n plus 1 cs. Now numbering it 2. From 1 we get Pn is equal to 1 over minus 2 into n plus 1 summation n is s is equal to 1 to n plus 1. So that is that value, that is minus 1 power n plus 1 minus 1. Therefore Pn is equal to 1 over minus 2 n plus 1 minus 1 power n plus 1 minus 1. Now we put n is equal to 2k, any number 2 times some numbers, then p of 2k is equal to 1 over minus 2k plus 1 minus 1 power 2k plus 1 minus 1, because we need actually p of 2n. So we want to find p of 2k type, then we replace k by n. So therefore it is 1 over minus 2k plus 1, here is minus 1 power 2k into minus 1 minus 1. This is gives 1. Therefore p of 2k is equal to 1 over minus 2k plus 1. Here it is minus 1 into minus 1 minus 1. That is 1 over minus 2 2k plus 1, that is minus 1 minus 1, that is minus 2. So this minus 2 and this minus 2 cancel. Therefore p of 2k is equal to 2k plus 1. Therefore p of 2k is equal to 1 over 2k plus 1. This implies p of 2n is equal to 1 over 2n plus 1. This implies 1 over p of 2n is equal to 2n plus 1. In question asked, find the value of summation n is equal to 1 to 25 1 over p of 2n. So put here the value of 1 over p of 2n and summation run n is equal to 1 to 25 2n plus 1. Now break this summation to come outside the summation. N is equal to 1 to 25 n plus summation n is equal to 1 to 25 1. Therefore that is 2 1 plus 2 up to 25 plus it is 25 times, that is 25. Now we know that 1 plus 2 plus 3 up to n is equal to n into n plus 1 by 2. So use here n is equal to 25, that is 2 into 25 plus 1 over 2 plus 25. Therefore summation n is equal to 1 to 25 1 over p of 2n is equal to, here 2 cancel, then 25 times into 26 plus 25. Therefore 25 plus 25 into 26 is equal to 25 common, 26 plus 1 is equal to 25 into 27, that is equal to 675. Now overall the questions we actually write Pn as a compact form in summation, then we write an binomial expansion 1 minus 2 power n plus 1. This expansion gives the value of Pn in very nice form. Then we find the value of p of 2k, some expression, then we replace k by n, then we get p of 2n, then finally get 1 over p of 2n and summation run for n is equal to 1 to 25, that value is 675.